Hey everyone, in this video, we're diving into a fundamental concept in leak repair, the void fill enclosure. We'll talk about what it is, how it works, and the types of sealants that are used. A void fill enclosure is a type of leak repair system where the entire internal cavity, the space between the enclosure and the pipe, is filled with sealant. I will show you what that looks like and how it works. So, to start, I'll describe a few features on a void fill enclosure. The first feature is the cavity, which you can see here. The second feature is the bore seals right here. The bore seals are usually packing like this that fit into machined grooves. Copper tubing or crunch teeth are also commonly used as bore seals. So the way that this enclosure works is that the enclosure is installed onto a pipe, and there's a space in here that exists between the enclosure itself and the pipe it's being installed on. That's what we call the void. Once the enclosure is fully tightened onto the pipe, injectable sealant like this is injected through injection ports in the back of the enclosure to fill up the cavity and to create a seal. That sealant ultimately fills up the entire cavity of the enclosure, and it will seal off all of the leak paths. What that looks like when it's all done is the cavity is completely filled up with sealant. So on an enclosure like this one, there are a couple of different leak paths which need to be sealed. The main one, or one of the main ones, is through the bores where the pipe lands on the pipe. There's a little bit of clearance between the bore itself and the pipe, so there's a leak path through there. There's also leak paths through the split line. The split line is where the enclosure comes together in half. It's not fully sealed, so that's a leak path. And then another leak path is through the injection ports on the back. I wanted to point out a key misunderstanding in the industry to do with bore seals. We call them seals, the packing in here, but they're more like a barrier that prevents injectable sealant from extruding. In most cases, they don't actually perform a continuous, reliable seal on their own without sealant. Now, a void fill enclosure can be used on almost any kind of service, as there is a wide variety of available sealant compounds. All the sealant compounds can effectively be divided into two main categories: curing and non-curing sealants. A curing sealant will harden after injection, kind of like cement turning into concrete. Here's an example of what a curing sealant looks like. You can see that the sealant here, represented by this green chunk, is completely hard. When that's inside the enclosure, this is what it would look like. So when it's completely hardened inside the enclosure, it forms a rigid cast-like barrier. One big advantage of a curing sealant is that it provides structural reinforcement to the pipe and the enclosure, which can be helpful in corrosive or erosive surfaces. If the pipe wall gets completely eaten away, the hardened sealant can act as a barrier between the product and the enclosure that can buy time and extend the life of the repair. Also, curing sealants don't wash away very easily, so they work well in abrasive and high flow situations. But there are downsides to curing sealants. Once they harden, you can't really re-inject them. So if they don't cure properly, or if there are cracks or voids in the material, you could end up with a leak that's nearly impossible to stop. I've seen cases where a curing sealant was used on an active leak, and during the injection process, the service mixed with the sealant as it was curing, and that caused the sealant to crack. So all of these little cracks existed within the sealant itself, and it led to a bunch of leak paths that became very difficult to fix. So if you're using a curing sealant, make sure any active leaks are securely patched before you inject. Now, the other type of sealant is a non-curing sealant. These stay somewhat malleable inside the enclosure as they do not completely harden. This sealant here is an example of a non-curing sealant. So it's kind of squishy, almost like a Play-Doh. The benefit of a non-curing sealant is that they can be re-injected if a leak develops later. They're also great for valve repairs where the valve still needs to function as in the case of an auxiliary stem enclosure. I cover that more in another video I made on auxiliary stem designs and active valve stem leaks. The trade-off with using a non-curing sealant is that they don't offer the same level of protection against erosive surfaces, and the sealant can be washed away more easily than a curing sealant. So to sum it up, curing sealants harden and create a rigid protective barrier, but they can't be re-injected. And they're sensitive to how well the leak is patched prior to injection. Non-curing sealants stay soft and can be re-injected if needed, but they don't provide the same level of structural protection. Now, from an engineering standpoint, I wanted to tell you about a few of my favorite features with the Void Fill Enclosure style. My favorite feature is their performance in cold weather. Since the entire cavity is filled with sealant, you don't have to worry about the surface inside the box freezing if it gets too cold. That's especially important with steam or water leaks in cold climates, as if the enclosure fills with water and then freezes, it can split the enclosure open. Another feature that I like with Void Fill Enclosures is that the bores are often smaller than with other styles of seals, as you only need to fit one seal groove in here. So that allows Void Fill Enclosures to be used in tight spaces where there's not a lot of pipe length to land on. But void fills do come with their own set of drawbacks. One of the main risks is external pressure on the pipe. If the pipe wall is too thin, or if the enclosure spans a really long distance, then the pressure from the filled cavity can cause the pipe to collapse. There's also the risk of mainlining, where sealant gets pushed into the service stream, and that's not good either. If you're interested in learning more about external pressure damage and mainlining, you can check out my videos on those topics. Another disadvantage of Void Fill Enclosures is their cost. Some sealants can run hundreds of dollars per stick of sealant, and with big Void Fill Enclosures, they require a lot of it. So in some cases, the sealant itself can actually cost more than the enclosure. Now, there are some lower cost options for sealant available, such as silicone-based sealants or pour-in epoxies, but there are many surfaces that require high performance compounds that aren't cheap. So when should you use a void fill? I recommend them when you don't have enough room to land a perimeter seal style enclosure. I also recommend them in highly corrosive or erosive surfaces where extra protection is needed. And I recommend them in cold climates where freeze-thaw cycles could be an issue. Personally, I would avoid void fills if you're dealing with a strong active leak that can't be patched beforehand, as the risk of mainlining would be too high, or if you're working with long or really thin sections of pipe that could collapse under external pressure. So to summarize, void fill enclosures are a great option when they're used in the right situations. Just be aware of their limitations and choose your sealant carefully. Thanks for watching.